What is up, guys? We're back, day 34, conference edition. I'm getting ready for conferences. I'm looking forward to seeing you guys come in, seeing some parents, and getting to work on this. I want to take a look at just a problem here, and I ask two questions about it. Here's our model. We have an object's velocity is modeled by v of t equals 8 cosine of the square root of x cubed plus 2 for 0 is less than or equal to t is less than or equal to 6. A couple of things to note here. No units were included with this problem, so we won't need units throughout the whole problem. So nothing to worry about there. Also notice that the equation we have is for velocity. The first question I'm going to ask about this prompt is A, is the speed of the particle, or the speed of the object, increasing or decreasing at t equals 1? Okay, so there's our question. This is obviously a calculator question. So the first thing we want to do here is we want to go to our graphing calculator and get that graph in there for our velocity, right? So let's go ahead and do that, and then we'll think about what this question is going to look like. So when we go to our calculator here, go to our y equals, and we're going to, again, put in the function 8, oops, get that out of there. Come on. Okay, anyways, we have 8 cosine of square root of x cubed plus 2. So here's our function. Before I hit graph, I want to set my window correctly. So I'm going to go to my window and I'm going to set my x min to 0, which it already is. X max I'm going to move to 6 because that was our whole thing. Now when I hit graph, I get this graph popping up here. Again, so we have this now. Let's go back to our question. Our question is the speed of the object increasing or decreasing at t equals 1? Go ahead and pause the video here and see if you can answer this question on your own. Okay, we're back. What we want to do, anytime we want to know if the speed is increasing or decreasing, we have to remember to check two things. Two things I need to check are, I need to know what is the sign of v of 1, and I need to know what is the sign of a of 1. Again, you cannot answer this question by looking at one of those alone. Okay, so when I go back to my calculator to find v of 1, since I have the graph of v here, I'm simply going to trace 1. When I trace 1, I get an answer of negative 1.284. So let's go back and put that in. Which obviously is less than 0. Okay, so that's part 1. I have the v of 1 I found out is negative. Now I need to figure out acceleration at 1, right? We know acceleration is the derivative of velocity. So let's go ahead and calculate our derivative using second trace, number 6. I'm going to type in 1. And I get negative 6.838. Which is also negative. Since my velocity is negative at that point and my acceleration is negative, they are the same sign. So I can say the speed is increasing at t equals 1. My justification here, because v of 1 and A of 1 are the same sign. We want to be thorough in our explanations, and we don't want to say things like because they are the same sign, right? The graders of this test need to see you specifically reference both velocity and acceleration. Good. Okay, so we've seen that before. Here is something new. On the interval, zero, 4, at what times does the object have a speed of 3? So I want you to pause here and just contemplate this question. What jumps out at you? A couple of things jump out at me. One, we are looking at a different interval than the original interval of the problem. We're looking at an interval of 0 to 4. Now I want to know when an object has a speed of 3. The word that really needs to jump off the page at you here is speed. Be very careful. Just like up here we needed to be careful when we saw speed in part A, we need to be very careful with speed in part B. A speed of 3 and a velocity of 3 are not the same thing. Remember, speed is the absolute value of velocity. So what different velocities could give us a speed of 3? Well, 3 obviously would, because the absolute value of 3 is 3. But so would negative 3. So going back to my graph here, first thing I want to do is shrink the window. I'm going to shrink my x min and max to 0, 4. Okay? And now I'm just going to take a look at this graph. And I need to figure out how many times this object hits a speed of 3. And at what times those occur. Well, one of the things that I remember when I was first using my calculator, right? If I trace, I can kind of move my cursor over, but I can't make the y hit exactly what I want it to hit, right? I'm looking for velocities of either 3 or negative 3. But by tracing, I can't get it the exact x value. Okay? Well, there's a very simple solution for this. We just want to graph the horizontal line of 3 and graph the horizontal line of negative 3, and then we'll just have our calculator find the intersection. That will give us the exact values we're looking for. Here's what I want to do. I want to go into my graph and graph 3. I also want to graph negative 3, because velocities of 3 and negative 3 are going to give us solutions to this question. When I graph these now, I can see there are for sure, looks like up here, there's 1, 2, 3, 4. Looks like there are 4 different times where this object has a speed of 3. Now, if you only looked at the positive 3, you'd miss those other 2 down there. So what I want to do now is just find these things and report them as the answer. So I go second calc intersect, number 5. And I just want to move towards that first intersection here. I'm just going to arrow over until I'm close to that first intersection. Now I'm dealing with 3 lines here. So I'm on the correct line now, but it wants me to use the line y2. I don't want that, so I'm just going to hit the down arrow to do y3. I don't have to be right on it, I just have to be close, and I'll find that first time. So the first time is at t equals 1.222. Or you could report it as 221. Either way is fine. They accept rounding or truncating. Okay, that's the first one. Let's go back to my graph and find the other 4. Okay, so again, I'll do second calc 5 for intersection. I just need to arrow myself over closer to that other intersection on the -3 line. As you're watching this video, go ahead and try it by yourself. Try it on your own calculator. So we got another one at 2.558. So let's go back and report that one. And I have 2 more to get. I'll do these quickly. Second calc 5. I'm going to move closer to that +3 intersection up here. I'll hit enter, enter, enter. And I get 2.884. And lastly, my last one I get here, this takes a little while, which is why you want to familiarize yourself with the calculator so you can do this quickly on test day. You're not trying to figure out how to use it during the test. And we get 3.775 as our last one. So those are the 4 times where we have a speed of 3. Again, these two came from a velocity of -3. These two came from a velocity of +3. The test is, when they do this speed question, they're always going to have some negative answers show up because people always forget that speed is the absolute value of velocity. That's it for today. Hope to see you guys tonight at conferences or tomorrow. Peace. 2 chains.